Okay, module 5 first half, that is chapter 3 in Edward Angel book, deals with input and interaction. What is this? This is pure theoretical. Some parts I have made some programs which I will explain it in a bit. If you look at module 5 first half, this is what you will deal with. Okay, it says about input and interaction. How exactly you can give input to any OpenGL program or perhaps any graphical application, and how we can uh, animate it or how can interact with an application. Of course, you know we use glut mouse func, glut keyboard func, glut idle func, glut mouse motion func, all those. That is basically used to interact with an application via your mouse, your keyboard. We saw this in couple of our lab programs as well. You remember if you take second program, uh, you know, if you take second program, let's close. If you take second program, as and when we uh, interact with mouse, that is right click. First option says to rotate around the origin. If you select second option, it goes to wherever point you have selected. Third program, fourth program also talks about mouse funk and window funk and keyboard funk as well. So if you press left click, the cube rotates in x-axis direction, middle click y-axis, right click z-axis. Fourth program talks about this as well as keyboard funk. If you press x-axis, the next button, the y-axis. So how exactly we dealt with? We saw that a couple of APIs. Now we'll go with official stuffs. All right. OpenGL, you can give inputs in two ways. One is physical inputs. One is called logical input. All your keyboard, whatever you press, that comes in logical. Physical input means you can see here there will be a physical input, and whatever you press here, that is called as logical output. For example, if you press A is the physical button, and the moment you press A's ASCII code gets A's ASCII code will be given as input to the system. That is your logical output. So various physical inputs, you can see all these are your data tablets, light pen, joystick, space ball, all this. Now logical inputs means you can take this example. There is int x scanf, take it and put it. The point is, the application really doesn't know whether it is coming from a keyboard or any other input. So that is the reason it is called as logical input. You can see here, printf requires no knowledge of the properties of physical device such as keyboard codes or resolution display. So keyboard is just physical, but in logical input devices, if you write this, the application need not have to know that whether it is coming from keyboard or any other input. It might be coming from your phone's keyboard as well. All right. So logical inputs can be of six types. One is called string, locator, pick, choice, valuators, and stroke. Now, what is string is the moment you press any key, it will return the ASCII value with the help of a physical keyboard. Locator means your mouse, where exactly your mouse is pointing at. In the sense, it is x comma y. Pick means you locate it and pick any item. For this, I have a program I will show later for this, as well as for the locator, as well as for choice. Now, choice means you pick it and select any portion. That is your choice. It can be your drop down menu as well. Valuators means some if you want to give any analog input, you will use this kinds of logical input. Stroke means it is the string array of strings. That means in string logical input, you will only press one key, and if you keep on pressing multiple keys, that becomes your stroke. You can see returns array of locations. Now various modes we have. We have three modes. This is important from the examination point of view. How exactly you can give the input. Now there are two um, stuffs that you can put it out. One is called as measure, one is called as trigger. Now measure is a device of a device is what the device returns to the application program, and trigger is with which use of a device is physical input on the device with which the user can send signal. To simply put, I'll make you understand in this way. Take a keyboard. Now let us say there is a key called uh, let us say D. Now D is the measure, and the moment you press D, that gets triggered. T is a physical input, that is a measure. The moment you press D, D's input will be triggered and D's ASCII value will be sent. That is what you mean by measure and trigger. You can see there are some examples here. Measure of a keyboard is a single character of array. You can say, let us say D. Whereas the trigger is the key pressed. For example, he has taken enter key. One more example. The measure of a mouse is the position of the cursor, whereas the trigger is whenever the mouse either left or right or middle button is pressed. Now based upon this measure and trigger, we have three modes. First mode is request mode. You should see from the reverse. There will be a program, and let us say I want to press a key called D. Now that D comes here in the trigger process. But before pressing D, I will go to the physical button called D. That is the measure process. Now you should first request that physical button called D, and this physical button will now trigger a logical input called ASCII code of D. That is called trigger process. This is how you request it. Now sample mode, wherein you don't require any triggers. So if you want your input to be very immediate, you can just go with simple mode. But what majority of the guys use is event mode. For example, if you take third program, second program, fourth program, and all, that means you can take your mini project as well, wherein your project requires your input from the customer as well. Either it can be mouse or keyboard as well. So that is what you mean by event mode. So all these measure and trigger happens if you have any event that needs to be processed. For example, you can see there is a program and you will request any measure, but that request will go to the event queue, and then it will be measured and then it will be triggered. So this is how any application program will run. So these are the various modes for any application program wherein you can give inputs. All right. That means if you press any mouse or if you interact with your application, event mode of input modes will get triggered. Just the theory behind it. Now, client server model, just to give you an overview, along with your CPU, there will also be a graphics server. That is what we spoke about, having a graphics card in your system. All this. So display list means, for example, let us say you want to draw a car. Now display list is a list of API wherein you will first draw, let us say, the wheels and the chassis, and then the engine, then the exhaust, all those. So display list means it's a list of all the display devices that needs to be processed. and it has two modes. One is immediate mode. Immediate mode means, let us say I want to draw a car now. It will be drawn without storing that on the server. Now, if you want to draw another car, you have to override this car with a new car. What is retained mode is everything you will keep on a server. You can see here on a server. So an application developer, if he wants to draw a car, all he needs to do is he should not draw the car. He should just call the function which is present in the server. You can see a simple function call issued by the client to the server. Client server architecture is here. So all the cars, any other application which needs to be drawn again and again, it will be kept on the server. And any application developer, if he or she wants to use or draw any object, just you need to place the function call. That is what we use something like this. For example, let's say I want to create a window. So I will just pass the argument and I will only call the function. So this create window function will be on the server. So whenever you call this, you will get a nice window like this with this argument called square demo. We'll come to this. Okay. Next is how exactly a display list can be defined. I will explain it via a program later. That in GL call list box, you should keep all your, for example, first is you should draw the wheels. Second is the chassis. The third one, the seats, all those engine, exhaust, all those. So in all this call list, you should keep on adding. You can see here in this function code. So in my call list, in my for loop, I'll keep on adding whatever I want. And then if I do push matrix, it will be pushed onto the server. So here this section talks about how will you draw a text. Now understand you can draw text in two types. One is called a raster, one is called stroke test. Now, for example, to draw a line, to draw a character called I, it is will be done in one stroke. Whereas, for example, to draw a character called O, you can see this kind of a midpoint circle algorithm, something like that. So it requires 13. I mean, it requires 13 0 to 12, 13 vertices to draw a circle. So everything you need to put it in your call list and then push matrix, and then you will get a circle called O. So yeah, you can see here, should keep on putting into list, and 256 ASCII values you need to have. There are 256 keyboard ASCII values. And once you are done with the list, just issue push matrix. So you will get O. Now all these are fine. These are least important, and yeah, you should use these two characters. And the important stuff comes from here. Programming event-driven inputs. Understand there are 3 to 4 types. One is called pointing device. One is called window. One is called pick. One is called animating it. All those. So these from this point the real class starts. In examination you will get 1 or 2 questions definitely from pointing or keyboard or window or any playing with all this. So what I have done is, you can see here I have 3 programs which will talk about all this. Okay, now let us concentrate on how exactly you can program your OpenGL application which is event driven. Means you show the output. For example, I'll show the output here. It doesn't show anything because it is event driven. Means any event happens, then only the output comes. For example, I'll press here, I'll get one red square here. I'll press here, I'll get a red square here. If I don't press, I'll not get anything. So if I press a right click, the program gets terminated. That is how we have written the program here. If you press left click, draw it. If you press right click, exit it. So that is what you mean by event driven stuff, event driven input. Now they'll ask you a question, explain how an event driven input can be programmed for a pointing device, for example mouse. All these we have seen already, and there is a program here. You can see, write an OpenGL program to display square when a left button is pressed, and to exit the program if the right button is pressed. So that program is here. To show properly, let me increase the size. Okay, so build it. You will get a window like this. So it is event driven, means whenever an event happens, it drives. So the program executes, So you press it. This is what is an example of pointing device here. An event driven input can be programmed for a pointing device. So as and when you create an event, that particular portion will be executed. So let's see how we do this. Now we basically use mouse func function. You can see here, let us start from the main. I'll use single buffering mode, my window size. Now what is this? WH comma WW, window height comma window width. Those are my globals. Window height is 500, window width is 500. I might as well copy it and paste it here itself, 500 comma 500, but better to put it in variables so that if your manager asks you to change the height and width, you can just change the variable name, and if that gets accessible in some of the programs, it will be reflected. All right, so create window, square window. Now display func of display. Now this is very this is a new concept when compared to all the other elements. Now in display, what we normally used to do is, in display we used to write everything, whereas here we are only clearing the screen. We are not doing anything. Why? Because of this. We should do event driven input. Means in display just clear it. For example, in display just give me a clear window. Don't do it. As and when the event happens, you start executing it. So how do I let my machine know this? So in the glut display func of display, so just clear the screen, or perhaps you can eliminate the entire thing and just don't write anything. In that case, you will get this. Build it. You can build and run. You can show this. Why white window? You can see here it is this 111. By default, whatever is this clear color, it will be default. And fourth parameter is your alpha. That's what I told you. You can eliminate the entire thing, but of course you need to have display. And I can clearly write nothing. Okay. In my next program, I'll show there is window. Yeah, you can see here void display void nothing. So in my, whenever I do let display func of display, it comes to display, it does nothing. Why? Because it is event driven. So whenever something happens, that is whenever I press my mouse, I'll do something. All right, we'll come to that later. Now coming to this, let display func of display. So it just clears the screen. Now this is the new stuff for you. Not new stuff. This is what we have seen in our second program, third program, fourth program, all those. Glut mouse func of my mouse. So my mouse is a function, callback function. It has 4 parameters. And understand, guys, the last 2 parameters, x and y, determines your mouse location. Now what he says, if button is left button and if you press it, call this function. In our previous cases, we used to do all this in display itself. because it is event driven, and in display you don't do anything, and whenever an event happens, you perform your event. Similar to your Java, action performed, all this. So if I press left button, so I'll call draw sq is the function name, and you can see here I am passing x and y, means where exactly the mouse location is. I mean where the current mouse location. Now if I press right click, I'll say exit. So left button, click it, you should call draw square. Now in draw square, pass xy. Xy is this, means the current location. So from current location, I should draw a polygon. Uh, Wherever is x plus size, size means is your 30. Wherever is your x, draw plus 30, means you should, for example, if I press here, the mouse cursor is here, from here plus 30, from here it is plus 30, from here plus 30, and plus plus minus plus minus minus plus minus is for your coordinates, means to say if I press one mouse cursor here, there are in polygon there are 4 points. The first point's coordinate, second here, third here, fourth here. So those coordinates are your four functions, four GL vertex, two ifs. Now once you end it, you flush it. Now the remaining guys, my init. Now in my init, what you do? So set your white color, and because the view changes, because the point is, you can see the current view is this, and if I press a new cursor, the old view gets vanished and the new view comes here. So that is why I need to have projected load identity and then again model. All right. Now ortho 2D, it is 0, view WW, that is window width 500, 0, 500. It is basically uh, LRBT, left, right, bottom, top, which is equal to 0, 500, 0, 500, which we have seen. Color 3F, this is what color? Red color. Red color polygon. So my init does that. This is a simple program. My init we have seen, draw square, display, my mouse we have seen. Main loop. So start the main loop again. So this is a simple program which you should write whenever if someone asks you how exactly you can do an event-driven input for pointing device. Now let us see for keyboard event. That is, you should use glut keyboard func. And you can write any of your fourth program. Fourth program talks about keyboard func, glut keyboard func. We have seen this, right? My key, and if key is whatever A, B, C, D, do this, and if key is Q, do exit. This we have seen already in fourth program. Now one more way is window event. Now this in window event, the reshape function comes. I'll explain this theory, all this, via a program. We also call this as a rubber band technique. Okay. Now I'll show the output. First you run it, you will simply get a window. Courtesy glut display func of display. In display, I'm not doing anything. You can see I'm not doing anything. That is the reason here. It is not doing anything. Now, as and when you press mouse func, in mouse func, if you press right button, it is exit. Okay, right button means exit. Now, what is the big deal? The big deal is for new guys, I mean, for you guys, the new concept is motion funk. We have already seen display funk, mouse funk, reshape, and keyboard funk. Now I am explaining you a new thing called motion funk. Now, motion funk means whenever there is a motion, mouse motion. For example, you can say I'll press left click and I'll move it. You can see the output. You can see here. Yeah. This is called motion funk. Now, this motion funk, uh, one second, motion funk of draw square. Now, the draw square is the function. So, that is here, here, draw square. Now, in draw square, I'll call polygon. Now, color 3, undefined byte. These are the various, for example, you can all these color combinations. Instead of giving GL color 3f of 0 comma 0 comma 0 or 0 comma 1 comma 0, what I'm doing is I'm I'm saying random divided by 256. Whatever is the remainder, you put it here. For example, that remainder can be anything. Let us say 0.25, comma one more random divide by 256, and whatever is the remainder, that can be 289, something like this, whatever. So those random colors and polygon. And basically, if you click one, and all these are polygons. Again, a polygon has four vertices, and these are the various positions. All right, that is your motion funk. Now, display funk of display, it does nothing, as I told you already. Now, motion funk, it is a continuous function, as and when there is a motion in the mouse, you draw these. Okay, now comes the main point, that is in the window events, my reshape. Now, to explain you this, you just, okay, run again. Now draw this, you will get the output fine. But reshape means you reshape the window. You can see the output is still the same. You can maximize this. Output doesn't get distorted. Now this we have already seen, and whenever you get this type of a question, you should write reshape. Means whenever the question talks about window, better write reshape. Now what is this reshape? There is this glut reshape func. This is the callback function, and you call my reshape function. Now my reshape is here. My reshape, it takes two parameters, width and height by default. Means this is the width and this is the height. So if you increase it, the corresponding width and height will be present in this W and H. Now, since you can increase or decrease, width and height will be present here, but the output doesn't, I mean, output should not get distorted. Courtesy is these guys. Okay. And viewport has four parameters, X and Y and width and height. Now, where exactly the cleverness comes is, if you write 0 comma 0 W comma H, means whatever is the current size, width and height, in the viewport I am taking the same size. Now if you do W by 2 here, H by 2 here, what really happens, you can see. So wherever you can see the mouse is here, the output is getting drawn here. So means to say, in the entire window, I'll maximize this. In the entire window, I am only using half of width and half of height. That means only this portion, that is the third quadrant portion. You draw wherever you want, only in the third quadrant the output comes. Why? Because in my viewport, I am saying width by half and height by half. You can ask me why only third quadrant? Well, if this is the window, this is 0 comma 0, and that is the bottom left, the where the pixel starts, or I can say the window starts, that is here, that is bottom left, hence it is third quadrant. Had it been starting here, that is uh, leftmost, then it would have entered, that it would have written in the second quadrant. Had it been started here, that is the rightmost, top right, I can say, so it would have started drawing in the first quadrant. Since the window starts here, that is the bottom left, not top left, not top right, not bottom right, so it starts in third quadrant. Means if you do w2 by 2, h by 2, like this, you can go ahead with saying w by 4, w5 4, h by 4, whatever. So viewport means where exactly you want to see. Clear color 000 means black color, and as and when you clear it, flush the screen. So this is very important for a customer if he reshapes the window. Now my explanation continues by commenting this. That means what really happens if you don't do this. That means if you don't do any event driven input for a window event, means you're not doing my reshape. So if you don't do my reshape, okay, output is here. Now comes, if you reshape it, you can see the output distorts. Why? Because if you reshape it, I am not at all considering the corresponding width and corresponding height. Yeah, we saw this in our demo of aspect ratio programs as well, right? So that's the reason it is very important for you to reshape it in your all. I mean, all of your mini projects should have my reshape function. All right, this talks about windows. You can see my reshape. This is what we have seen. All right, next is display func, we have seen, and idle func I have showed you, I think, in fourth program. So whenever I think third program, so whenever I am idle, the program should do something. So that is what it is. Now comes the interesting topic called menus. Menus we have seen in our programs, that is second program, or in our other theory classes. You can add a menu entry. First of all, you should create menu entry and then keep on adding menu entry. You can see let add menu entry. What is the English that you want, and what exactly, I mean, if you press what, you should get what. For example, if I press 2, I should get something. If I press 3, I should get something else. That is your menu stuff. This is also important. Now comes picking, which we haven't done. Picking means picking and selecting some portion of the output. We use what is called as pick matrix. That is that, yeah, here, GLU pick matrix. I'll show this via a simple program. Yeah, I have here. So we have used GLU pick matrix. Okay, well, this is a very interesting OpenGL API. Let me show the output first. Okay, please look here. Now this is the black screen, blue rectangle, and blue rectangle has been overlapped with red, sorry, blue square is overlapped with red square, and you are not seeing some portions of red buffer, red square, courtesy our depth buffer algorithm, which I taught in my theory class. You can see the YouTube video as well, how exactly this gets hidden, that is hidden surface removal, Z buffer algorithm or depth buffer algorithm. That is the reason you are not seeing red pixels here. All right. Now this program talks about two things, three things in fact. Now, wherever you click on the blue portion, that is non-hidden surface, for example, you can see here, you should see this window as well. So if I press only on a pixel, that is only on a blue pixel, you can see here the output hits equal to 1 blue rectangle. And if I press completely on a red pixel, I'll get a output here hits equal to 1 red rectangle. If I press here, that is the point. That means this particular pixel has both red and blue. So if I press here, you can see hits equal to 2 red rectangle as well as blue rectangle. It should have been like red pixel and blue pixel. This is the third one. Fourth one is if you press, if you don't press on any of these square pixels, let us say I'll pick here. That is what you mean by pick and selection. Now if you pick here, you can see the output hits equal to 0. So you press all here, you can see hits equal to 0, hits equal to 0. If you press only on blue pixel, hits equal to 1 blue. If you press only on red, so it is hits equal to 1 red rectangle. And if you press these portions, that is the intersection portions, so you will say hits equal to 2 red blue red blue, and these guys it's equal to 0. So I am picking it and I'm selecting it. That is the portion. So instead of just explaining you the theory, I thought I'll use all these in a program. So that is this program. Now let's see how we do this. Now understand there are two new things. One is called a render mode, one is called pick matrix. Now render mode, if you write gl underscore select, means whenever you pick it, those pixels will be selected. That is what you are basically saying for render. You can see the same here. OpenGL provides selection mode to do picking. The GL render mode means this guy. GL render mode should have GL select default value, GL select inbuilt value. Now comes these APIs. You can see GL pick matrix creates a projection matrix for picking that restricts drawing for these area and center at x and y with viewport VP. That is what you're seeing. Double X viewport of this viewport means it restricts with only this here. Okay. Now, apart from this, everything is self-explanatory. Whatever we have seen all this. So create a window of argument 0. Argument 0 means you can see here this window. Argument 0 is by default the path name. So that is what it doesn't have any value, any text here. I mean our own text here. So you can do that as well. Init, yeah, just clears the screen. That is the black screen. Means to say, the moment I do it, I'll just in the initialization, I'll only give you the black screen. Now, whenever I do display func of display, Yeah, display. It should not be blank, of course, right? Because whenever you display it, I am displaying two square boxes. So clear the black screen and draw objects. Render it. Draw objects is your function. So one more new thing, and of course, if the mode is select, you should give the names for this. So I am giving that blue window or the red window the name as one, and RGB the blue window the name as two. So I'm giving load names. You can see the load names here. Initialization names, load names, replaces the top of the name stack with the name. I'm just giving the name. I mean to say, whatever is the theory, I'm trying to explain it via a program. You can see this. All right. Mm. Okay, I'm just giving name, a red name as one, and the blue, I mean red square as one, and the blue square as two. And you call rect. Now understand, rect is a inbuilt function which is used to draw a rectangle, and f is your floating point parameters. You can hover the mouse here. There are four parameters: x1, y1, x2, y2, and process hits. That is to show here hits is equal to 0, hits is equal to 1. So this stuff is being written here. So whenever my pointer is one, red one, else show print brew and keep on incrementing your pointers. This we have seen. Mouse means to say whenever you can see mouse func of mouse. Whenever I press this mouse is the function name here. You can write mouse VVV, and similarly you should also write here VVV. So this is my mouse function. If you press left button, what needs to be done? And interestingly, if you press right button, only left button is here. Okay, that means you can see here, you can only left button is happening here. Right click, middle click, it is not taking. Why? Because if button is equal to left button and button down, you are doing all this. You can write else if glut right button and state is equal to down, exit. You can do that. Now here main thing that needs to be considered is selection and pick matrix. It's a projection matrix and it projects whatever you have picked it. All right. So that finishes off your mouse func and keyboard func. In keyboard, case 27. 27, find out the 27's ASCII value, and if you press that key, it exits. Uh, yeah, I think it's escape. Yeah, you on it left. Okay, fine. And if you press escape, it exits. So escape is the ASCII. I mean, 27 is the ASCII value of escape. So this finishes off your mouse various input modes. So I'll repeat. We have event driven. We are event driven, guys. One is called pointing, one is called keyboard, menu, window, and picking and selection. And all this is what we have seen in program. This is not there in your syllabus, and building interactive model means whatever we have seen, how exactly you can animate. That is combination of all this, whatever we have shown. So how do you animate it? Of course, it should interact with your mouse, keyboard, joystick, any other input models. And combination of whatever we have seen, all these three programs, that is how you can animate it. So this finishes off your module 5's first half, and second half is where your Bezier curve comes, and Bezier spline curve, Hermite curve, and all those things I'll do perhaps on Monday or Tuesday. And I heard in the current meeting, mm, yeah. So in the current the meeting which happened, I think half an hour or 1 hour back, HOD said there will be a third test on. Take a note, guys. Uh, June 11th to 13th. So June 11th to 13th, third test, and the portion is just module 5, and you need to answer 3 out of 5 questions. It will be 1 hour, 10 minutes, 10 minutes to upload and 1 hour to write. So totally it's a 70-minute test, and you need to write 3 questions out of 5 questions. So module 5, first half is done. Second half, Bezier curve is done long back, and a couple of things which we'll do subsequent classes. Any doubts? I'll upload this in YouTube, and you can ask me any doubts here. If you don't have any doubts, you can please put your attendance in the chat window. So thanks for your time. Thank you. You can mark your attendance here.